Okay, so in this question we're given 3 equal sized circles and each circle is 4 centimetres in radius, and we can see here there's a shaded area. Now we're being asked to find out what the area of this shaded area is. So how are we going to do that? From the information, all we're being given is that the sizes of the circles is the same and the radius is 4. So we have to use a little bit of geometry. So if you can somehow find the area of these little bits here and then subtract from the whole circle, we're going to be left with what that shaded area is. So first of all, let's find out the area of one of these. So we'd have to start off with a little bit of geometry. So we know that this here is going to be 4 and this here is going to make a straight line. So we've left with 4 right angles. So whenever you see right angles, the first thing you think of is trigonometry. So that's what we're going to do. So if we make a triangle, we can find out the area of these triangles here, which would have the same here, so there'll be 8 triangles altogether. So let's try and do that first. So as this radius is 4 and these are equally spaced half sides of the circle, we'll know that each one of these is 2, so this will be 2 here as well. And as this is a radius, that's also going to be 4. So if we can find out this side here, we can then work out what the area of the triangle is. So first of all, with Pythagoras, so a squared equals b squared plus c squared. So that's 4 squared equals 2 squared plus c squared. So therefore, by Pythagoras, c equals square root of 16 minus 4, which equals square root of 12, which is also, doing your thirds, is 2 root 3. So that's the area of one of those. So that's the length of that side there. It's 2 root 3. Okay. So now what we do, area of a triangle, 2 times 2 root 3 over 2, which gives us 2 root 3. Okay. Now, for 8 of those triangles, we need to just multiply this up by 8. So 8 triangles is 8 times 2 root 3, which is 16 root 3. So that's the area of the 4 triangles. Now what we need to try and find is these little bits here. So how can we do that? Well, we know we can see a sector here. So if we draw a line down here and a line down here, somehow find this angle, we've got ourselves a little sector here. And the formula for an area of a sector equals the angle divided by 360 times pi r squared. Well, we know what the radius is, because the radius is 4. This angle here, we don't know yet, but as it could be taken from twice this angle here, so if we get this angle theta here, double it, that'll give us the angle for this one here. So how are we going to find this angle? Well, CAHTOA would be a good start. So what have we got? We've got the adjacent and we've got the hypotenuse. They look like the easiest numbers to work with, as they're 2 and 4. To work with the 2 root 3 could be a little bit tricky. So adjacent and hypotenuse, straight away we're seeing cosine. So therefore the inverse cosine equals adjacent over hypotenuse, which is 2 over 4, which equals a half. And the angle that we know that equals a half, we know is 60 degrees. So therefore this angle here must be double that. So this is 120 degrees. Okay, so now on to this sector formula. Angle is 120 divided by 360 times pi times the radius squared. So 4 squared is 16. So that equals 16 pi over 3. Okay, now just to make sure we're on course here with the 8 triangles, working with both bits at the same time, we've got 2 of these sectors. So we times that by 2 and we end up with 32 pi over 3. Okay, now what we need to work out from that, if we draw a line down here, we've now got the area of this sector. There's going to be the mirror image, of course, because the circle goes here. So we've got the area of the sector, which is 32 pi over 3. And we've got the area of the triangles. So the triangles come down here like this. So if you get those 2 sectors and subtract the 8 triangles, that will leave us with these little sections here. So sector's 32 pi over 3. And if we subtract 16 root 3, that will give us the area of 2 of these parts here. Okay, so 32 pi over 3 minus 16 root 3. So let's just, 32 pi over 3, let's just get this one over 3 as well if we can. So that is also the same as 32 pi over 3 minus, divide that by 3, we want a 48, don't we? 48 root 3 over 3. And of course we've only got 2 of these, but we want 4. So therefore what we do is we got, so times that by 2, we've got 64 pi over 3 minus 48 root 3 over 3. Okay, now we've got the whole of the area of all of these bits now. So now what we need to do is find the area of the circle. Well, a circle is just pi r squared. Which equals, as we know from the previous calculation, 16 pi. That's 16 pi. So if we take 16 pi and subtract this value here, that's going to give us our answer. So 16 pi minus 64 pi over 3 minus 48 root 3 over 3, that will give us, now to do that we need to make this over 3, so we can subtract the 64 over 3 pi. So now we've got 48 pi over 3 minus 64 pi over 3, and minus minus will give us a plus. Now we've done 48 over 3 root 3 here, we didn't really need to, so we can just bring that back down to 16 root 3. Okay, so now what we'll do, just simplify this up a little bit, just make it a little bit more tidy. 48 pi minus 64 pi over 3 gives us minus 16 pi over 3. Well, let's put the 16 root 3 at the front. Minus 16 pi over 3. And that, ladies and gentlemen, is your answer. Okay, tough question that.